All right, hey guys, Mr. Kyle, Myers Mathematics, and let's just jump right into it. This is factoring trinomials. It says a greater than 1, but I mean, a could be pretty much anything that's not 1 or 0, so it could be like a fraction or something as well. But we're just dealing with nice integers here. So that's what we're going to do, and I'm going to show you the steps for this. If you're trying to solve trinomials, there's actually a faster method, but it only works when you're trying to solve the trinomials, not when you're just trying to factor them. So if you're trying to solve, there's another method that's a little faster versus if you're trying to just factor and get the correct factors. Okay, so in order to factor them completely, there's a method, and this is actually the very first video I ever did, and it's called Two Truths and a Lie. And first video I ever did. So if you wanna laugh, you can go check that out. I might put that as the suggested video at the end of this one. So you can go check that out if you want to see something funny. The very first video I ever put out on YouTube. But that's what we're gonna do today. Is two truths and a lie, like the icebreaker. Except with this one, it's there's two things, and at least one of them is a lie. So it's called Two Truths and a Lie, but basically it's more like I'm going to tell you two things, and at least one of them is a lie. And you have to figure out if one or both are lies and expose the truth. That's specifically what we're going to do here. So let's go ahead and jump in with this first one here. We're going to have to multiply these two. So 3 times negative 5. And then we want factors of negative 15, which is pretty much just 1 and 15 and 3 and 5. Okay, except we need either the 1 or the 15, not both, to be negative, so that way it multiplies to negative 15. I'm going to make this negative and this positive, because if I make the smaller number positive and the bigger number negative, then when I put them together, I get a negative number. And I want to get a negative number. I want to get negative 2. All right, so let's write all of that out in steps here. So step 1 is to multiply the first number. Multiply the first and last number. Okay, aka a dot c, or a times c. Okay, that's step 1. Multiply the first and last number, a times c, which I'm just going to call ac in the future. So if you see me say ac or say ac in the future, that's what I'm talking about. I'm talking about the step 1 product. Okay, so then we want the factors. All right, so then it's factor time. I almost wrote that. We want factors of AC. Okay, and that's what we did. So now we're pretty much on step 3, and you don't have to do all of these steps in your out on paper, like written out. But if you do, then it is really nice because you can see all of the work there, and you're more guaranteed to get the right answer. And I wouldn't recommend doing all of this in your head and trying to just spit out the answer, because that's how you make mistakes, and your teacher probably would want you to show work anyways. So, anyways, factors of AC. And then step 3, we want to put those factors together. So we want to add the factors. Add factors. Right? And then step 4 is basically like a selection process. So that's negative 14. That's negative 2. We want the factors that add to the middle number. So we want to, well, not select. We want H and let's call it H and K. So H and K. This is what I like to call the factors. H and K are also the vertex, so don't get it confused with the vertex of a parabola. But I like to call them H and K, because you're probably fairly familiar with that maybe by now. So H and K are the factors. So they are the factors that add to B, which is the middle number. Okay? So H and K are the factors that add to B, which is the middle number. They add up to the middle number, which is these two right here. those two add up to the middle number. So that means those are h and k. And then step 5 is basically this. We do ax plus h and ax plus k. So we're going to create two a's, basically, which this is the part where a lie comes into play, because if you were to multiply this back out, it would not equal what we have at the beginning yet. But let's go ahead and do that next step. So we put ax, which means the first number and then the x. Well, in this case, it's a p, but same difference. So 3p, right? So 3p plus 3, aka ax plus h. So the 3 happens to be from this 3 right here. And then the other 3 is because of the factor of 15. Okay? And then I do it again right here, 3p minus 5. Right? So that 3 also comes from right there. So 3p minus 5 and 3p plus 3. Okay, not an equation. I just have that negative 2 there because I needed that for the step where I add up the factors. And then what I do is I divide out the lie. So we divide. Do we divide? I could have wrote that out actually. Let me do that. Let me write the symbol for that so it saves time and space. So we divide the lies. And there could be more than one. In this case, there's only one, but later on, there might be more than one lie, and we have to divide them both out. So we divide out the lie. The lie is going to be if there's a GCF, right? AKA any GCFs. Any GCFs, right? Greatest common factors. So for 3p plus 3, there is a greatest common factor. But that's a lie because there is not actually a greatest common factor of 3. If there was, it would have had to have been at the very beginning. Number 1 said 3p squared minus 2p minus 5. There's no greatest common factor in those three things. But somehow there was now, but that's because we created an extra factor of a. There's the lie. I divide out the lie. And what's left over is the truth. So once we divide out the lies, we're done. What's left over is the truth, and we have it completely factored. This is the answer. Pretty cool. All right, cool. So that is how we solve number 1. I'm going to do the same thing for number 2. Obviously, I don't need to write out the steps again, but I'm going to follow the steps just like I did for number 1, and just, follow each step to a T like I did for number 1. And then once we keep going here, I'll start to consolidate some of the steps, do some of the steps in my head instead of writing them all out, and start to go a little bit faster as we go. That way you can see what it looks like as you start to progress in this topic and become a Pokemon master at factoring trinomials. So let's go ahead and do the next one here. All right, so step 1, AC, multiply the first number with the last number. Then we want factors of 18. So 1 and 18, 2 and 9, 3 and 6. Except I want one of them to be negative again. If I make those negative and those positive, I'll always get a positive, and I want a positive this time. Okay. And it's not a big deal if you put the negative in the wrong place, as long as you don't try to put 2 negatives on there, because that would multiply to a positive. If you did like an extra set of factors, like let's say you did -1, -2, -3 with positive 18, 9, and 6, but then you did another set of 3 factors, which was +1, -18, +2, -9, +3, -6. That would be like all the factors. You could do it that way as well, and then that way you could just add them all up and figure out which one is which and get the factors we need to get. But that's going to be 17, that's 7, and that's 3. Oh, hey, there we go. We want 3. We want to add up the factors, step 3, so we did that. And then step 4, H and K are going to be the factors that add to B, which is the middle number. And that would be the -3 and the 6. So then we put step 5, AX plus H, AX plus K. So A x plus h, ax plus k. Scribble that out there. And then step 6, divide the lies. There's going to be at least one lie. There might be two, but there's going to be at least one. And it looks like the lie is right here because there's the GCF of 2. So the final answer is 2n minus 3 and n plus 3. And there we go. All right, now we're going to start consolidating the steps. Now that I've worked out the steps, followed the steps to a T, we're going to start consolidating the steps a little bit. Starting with not visibly adding the factors. Okay, so we're going to get rid of that step next. Oh, I almost wrote 14. JKLOL. That's going to be 12. So 1 and 12. Right? 1 plus 12 is 13. That's not going to work. 2 and 6. That adds to 8, but I want negative 8, so I make that negative, negative. And so I'm going to just stop there. So what I'm doing here is, as I'm starting to consolidate the steps, I'm actually adding the factors as I get the factors. So I get the factors, I add them up, and I see if I get the middle number, and then I stop once I get the factors I need to get. Right? So that's a little bit of consolidation there. And then I do AX, divide out the GCF. Okay, so that was step 5. And step 6, dividing out the GCF. 3n minus 2. And that's going to be n minus 2. Right, and that is the answer. All right, on to the next one. So that is a 5 and a 12. 5 and a 12, that makes 60. Okay, so what I'm going to do to consolidate a little bit more now is, well, no, I'll keep doing what I was doing earlier. 1 in 60. Well, no, we can do the factors in our head. 1 in 60, right? That's not going to work. That adds to 61. 2 in 30. Nope. 3 in 20. No, but getting closer. 4 and 15. Yes. 4 and 15. Multiply to 60, and they add to 19. Okay? And if you're not sure how to divide a number by a bunch of different numbers, that's okay. There's some tricks for that. You can actually go check out a video on that. I have a video on divisibility, how to tell if a number divides by another number quickly in your head without having to do it in the calculator. It's actually faster to do some of these tricks in your head. So when I'm dividing by 60, if I divide it by 2, I take half. If I divide it by 3, I'm just dividing 6 by 3 and then tacking on the 0. If I'm dividing by 4, I take half and then I take half again. If you divide by 5, then you would double the number and then move the decimal place over to the left, aka slash a 0. And there's just a bunch of cool divisibility tricks. So I have a video on that that I might remember to put in the link in the description below. If not, shoot me a comment and be like, oh, hey, you forgot to put that video in the link to that video in the comments. And I will do that. So 4 and 15 are the ones that work, and we throw 5s in front. So 5n plus 4, 5n plus 15. Divide out that GCF. 5n plus 4, n plus 3. And there we go. Okay, we used a lot of blue. Let's switch colors. Let's go to the next most prominent looking primary and secondary color here. We'll just kind of go through the color spectrum, at least primary and secondary. I'm not going to get too crazy. So let's go on to the next one. All right, that's 10. And we want factors of 10, which is going to be 1 and 10. 1 and 10 make 11. Put the 2n in front. 2n plus 10. Divide out the 2. 2n plus 1. And n plus 5. And there we go. All right, so we're starting to consolidate a little bit more here. The next thing we can do is we can consolidate the first step. So you can multiply the first number, the last number in your head, and then get the factor. So 2 times 2 is 4. Factors of 4 are 1 and 4, which add to 5. So I want 1 and 4 that add up to 5 multiplied to 4, which is AC. And then I put 2 in here and a 2 in there. Divide out that GCF, and I have 2n plus 1 and n plus 2. And there we go. All right, on to the next. It looks like, does that do it? I don't think that divides by 7. No, that doesn't divide by 7, not yet. I was thinking because I was like, wait, hold on, because I saw the 7 and the 28, and 28 divides by 7. And I was like, does 53? And then I was like, no, because if you add 7 to 53, it's 60, and 60 definitely doesn't divide by 7. I was trying to remember what it was. I think it's 56. Yeah, 56, 8 times 7. It just kind of threw me for a second there. So we want to multiply these. Oof, that's going to be a rough number. 7 times 28. 7 times 8 is 56. So that's a 5, 7, 2, 14, 19. 196. Yeah, that looks like that makes sense. So then we want factors of that, which are going to be 1 in 196. 2 would work, but I think that's going to be too big still. 3 doesn't go. 4 would go. 4 and 49. I could take half and then take half again. Or you can take the factors of 28. Factors of 28 are 7 and 4. So then I kind of just redistribute those factors, like 7 times 7, and then multiply that by 4. So that's what I did. But you could also use the halving trick. So if you take half of 196, it's a little bit hard, but you could kind of take half of each digit individually, like half of 100 is 50, half of 90 is 45, so now we're at 95. And then half of 6 is 3, so that makes 98, and then do it again. So half of 90 is 45, and then half of 8 is 4, so 45 and 4, which makes 49. So that's a little bit I don't know, just if you can use a calculator, use a calculator. That one's a hard one to do divisibility tricks on in your head. So anyways, we found the factors because 4 plus 49 is 53. So we put, excuse me, some 7s in front. I have like hiccups today. And then there, and then we divide out that 7. 7a plus 4. Ooh, I was going to go a little bit further and consolidate a little bit more on that step, but then I saw the 7, and I was like, no, because 7s are tough. 7s are tough numbers to multiply and divide by. All right. On this one, number 8, there's actually something we can do first. So when I said here's the steps, those were the steps for the actual factoring, but there's kind of a precursor, like a step 0, if you will. Before you factor anything, you actually want to look for a greatest common factor first. Out of like the 3 things, if there's a greatest common factor, if all 3 things divide by something, you want to divide that out first. And that's what's going on here. Each of these things divides by 3. So I'm going to divide each one by 3. And that gets that 3 to factor out. 9 over 3 is 3, so that's 3k squared. 66 over 3 is 22k. 21 over 3 is 7. Okay? And also, if you forget to factor out that 3, the 2 truths and a lie method will give you a slightly incorrect answer, because it banks on the fact that what you started with didn't have a greatest common factor. That's the lie. The lie is that there is a greatest common factor when there shouldn't be. So if you forget to take out a greatest common factor, and you have to do my method, 2 truths and a lie, it won't give you the right answer. So be really careful with that. You have to factor out that GCF first for this trick method to work. Okay, so anyways, that's going to be 21, which is 1 and 21 to add up to 22. And then we put 3k's in front. 3k. 3k. Divide that by 3. So then I get 3k plus 1. Oh, there's a 3 right here, because that 3 drops down. 3k plus 1. And k plus 7. Okay, so if you had done 2 truths and a lie on this before you factored out the 3, you would have divided out an extra 3. and that wouldn't have been right. You would have just gotten 3k plus 1 and k plus 7, which is close to the right answer, but you do need that other 3 factored out, not just divided out. So be really careful with that. Okay, on to the next set. So we're on to the next color. I'm going to do like a gold instead of a yellow because it's a little easier to see. Again, we get that 3 thing going on. All these divide by 3. So we're going to divide that out. So 3, that's going to be, I almost wrote a 15, I think. 5 n squared minus 9n minus 2. Okay, 5 and negative 2 are negative 10. 1 times negative 10 would be the factors, 1 and negative 10. And then I put the 5's in front. Boom, boom. 5n minus 10. That 3 stays out there. Divide out the lie. 3, 5n plus 1, and n minus 2. And that's the answer for that one. Okay, number 10. This one does not have a GCF, so we're just going to go add it again. And these numbers are not too bad. So what I'm going to do is I'm going to consolidate a little bit further. I'm going to actually divide out the lie here as well. Okay, so this is only once you get really, really good at this topic and you feel comfortable enough doing this, but we would kind of do pretty much all the steps in our head at this point, right? So 5 times 9 is 45. Factors of 45 are going to be 1 and 45. 3 and 15. Oh, there we go, 3 and 15. So negative 3, negative 15. And then the negative 15 would divide by 5. So the negative 3 stays. The negative 15 would divide by 5. So the negative 15 divided by 5 would be 3. And that would be what happens if you do all the steps in your head. That was actually a little bit tough even for me. So unless you feel really, really confident with it, I probably wouldn't recommend doing all the steps in your head for this. This is a really tough topic. A lot of people struggle with this topic. So if you are feeling pretty confident, just be careful not to feel too overconfident. And also your teacher probably wants to see work and not just the answers. Because if you had just the answers, they might think you're cheating. And then you have to, be like, oh, no, I'm actually just a super genius. So, yeah, just be careful with that. Let's go ahead and maybe we'll just show the factors for 11, and then we'll come back to doing it all in our heads again. So 4 and negative 25, that's negative 100. That's going to be 1 and 100, 2 and 50, 4 and 25, of course. 5 and 20. There we go, 5 and 20, because they subtract the negative 15. 5 and negative 20. So we want to do 5 and negative 20. Right? That multiplies to negative 100, AC. And they add or subtract to negative 15. All right, then we throw some 4n's in front. 4n's. Divide out the lies. There's only one lie again here. We haven't come across the 2 lie scenario yet, but we will. Pretty soon, I'm sure, because we're coming to the end of the worksheet here, so it's likely it's going to happen at some point here. This looks like a perfect square. So the reason why I think that looked like a perfect square is because both of these are square numbers. Now for 11, both 4 and 25 are square numbers, but 25 is a minus. It would have to be a positive in order for it to be a perfect square. If you think you might have a perfect square, you can actually try out the perfect square method, which I have another video on that actually. But the perfect square method is kind of cool. It's kind of like a difference of squares method. You take the square root of this and the square root of this. And I'll do the other method off to the side as well. And then that would be 2x, and that's 7. Notice I didn't put a sign in the middle yet. So 4x squared, the square root of 4x squared is 2x. The square root of 49 is 7. Then you put the sign of the middle number in between them and square it. But if you're going to do this method, you have to check it because, like for 11, it was 4n squared, which has a square root, and 25 has a square root, but it was not a square. It was 4n plus 5 and n minus 5. So because that's a thing, we want to check it just to make sure. We would want to multiply it out. It would be 2x times 2x is 4x squared. 2x times 7 which is negative 14x, and then we would have another negative 14x. Negative 14 would be negative 28x, which is not negative 35x. So it was not a square after all. It just kind of looked like it, right? So you have to be careful. If you think it might be a square, it could be faster, but if it's not a square, then you're kind of back to square one, so to speak. So anyways, let's go ahead and try our regular method on this one. So we would want to multiply the 4 and the 49, which again is that 198 number, right? We actually did that earlier. Oh, did we? Oh, well, yeah, it was 4 and 49 were the factors, but yeah, it's 196. We actually just got that same number earlier, 196. Okay. And these I write out a little bit more because they've got sevens in them. Anything with a factor of 7 in it is just going to be harder because sevens are terrible. So we want factors of this, which it'd have to be more than 4 and 49. 5, 6, 7. 7 and 28. Yeah, that would work. That would add up to negative 35 if we make them both negative. And then we put 4x's in front. 4x. Divide out the lie. 4x minus 7 and x minus 7. And there we go. Okay. So then we're on to this next set here, which I think might be the last set. This might be, oh, nope, just kidding. There's 2 more after this next set of 4. So I'll get to go to 1 more color here. The orange, the gold kind of looks like orange, so I'm actually thinking I might just go ahead and go right to red. So there's a little bit more contrast there. Okay, let's do some of this in our head again. This is also a potential squares thing, but it's not going to be. Spoiler. So anyways, 4 times 4 is 16. We'd want 1 and 16. We want them both to be negative. 1 and 16. We want negative 1, negative 16. And then we would have 4n minus 1 is going to be one of the factors. The other factor would be 4n minus 16, but that's a lie. We can divide out the 4. If we divide out the 4, we get that. Oh, also, one of the things that I haven't really mentioned yet that I really would recommend doing, especially if it's on a test and you have time to do this, is to multiply it back out, FOIL it back out. First times the first, 4n squared. Outer times the outer, negative 16n. Inner times the inner, negative 1n. And then last times the last, positive 4. 4n squared minus 17n plus 4. We're back to where we started, so we know it works. That is the perfect way to check your work, is to just FOIL it back out and see if you get back to where you started. Okay? Foiling and factoring are opposites, so it's a great way to check your work. Okay, 49. That has 7s in it, so we're going to be really careful here. 49 times 6. 9 times 6 is 54. 5. 6 times 4 is 24. Plus 5 is 29. That's a negative, and we want factors of that. Okay, there's a lot of factors. There is 1 and 294, of course. 2, 3 would work. Man, lots of factors. 3 would go in, but I don't think that would be big enough yet. Because 6 and 49, if I subtract those, I get like a 43. And I need them to subtract to positive 7. So I need the factors to be close enough to where they would subtract to a small number. So what I need to do then is I need numbers that are bigger than 6. So I don't need to check all of the factors before 6 because they're just going to be ridiculous. 1 and 294, if I subtract, I get 293, positive or negative. And that's way too big. I need to get 7. So let's just go straight to 7. 7 would be the next one after 6. If we divide 49 by 7, we get 7. 7 times 6 is 42. No, still too far away. 8, 9, 10, 11, 12, 13, 14. 14 might work. 14. So we would do a factor of 2 from the 6 and a factor of 7 from the 49, which would leave a 7 and a 3, which makes it 21. And that would work. 14 and 21. There we go. Okay, so then we have 6x. Make a little dividing line here. 6x and 6x. And here is finally where we have two lies. You probably thought I was lying about there being two lies. But there's two lies here. This one divides by 2. This one divides by 3. So if we divide the first one by 2, we get 3x minus 7. And if I divide the other one by 3, we get 2x plus 7. And that is the final answer for that one. Whew, that was a doozy. Okay. So then, for this one won't be as bad. 6 and 6 make 36. 1 and 36 add to 37. So we want 6x plus 1. And then we would have 6x plus 36, but that divides by 6, so it's going to be 6 and x, which is x plus 6, if I read that the correct way. And there we go. That's it for that one. Next one. All of these have a negative in them. I think that's going to make things more complicated. I don't think there's anything else going on there as far as greatest common factors other than a negative, but I don't like that there's a negative. So we're going to factor out that negative. 6a, 25, and 25. Okay. And then 25 times 6, that's going to be 6 quarters, which is $1.50, so that's 150. And then we want 150 to give us 25. I think that's going to be 15 and 10. These are going to have, this is going to be another two lie one. So I'm going to go ahead and write this one out because I don't know if I'll be able to keep all of that in my head without going a little bit slow. So 6a, the factors are 10 and 15 plus 10. 6a plus 15. And that's a 5. And then we would divide this one by 2. 3a plus 5. And oh, there's a negative out in front there. Sometimes I just forget to carry it down because I'm focused on the main stuff here. But don't forget to carry that down. And then this one we would divide by 3. 2a plus 5. And that's it for that one. Okay, we're on the last two here because at this point we're getting to the answers. So I'm going to switch pen colors one more time here. We're actually can pretty much run the gambit. I did like a gold, which kind of counted for yellow and orange, but we've pretty much done all the primary and secondary colors other than that. So we're going to round these off here and just do the whole thing in our head for 17. For 18, I don't know if I can. I'm going to try. We'll see. Because you have to factor something out first. I don't know if I can do that all in my head, actually. If you can, let me know in the comments. I think I could, like, if I really wanted to. I just don't know if I would want to because I feel like doing it all in my head, I'd have to be really careful and make sure I like say the number in my head enough times to keep it there in my working memory while I'm like off doing something else, and then coming back and grabbing that number, which is a skill that needs to be developed, I think, and I don't try that hard to develop that skill because I don't really need to. I'm not like a memory competition competitor person. So anyways, 6 and negative 6, that's going to be negative 36. 1 and 36, 2 and 18, 3 and 12. 4 and 9. There we go, 4 and 9. So 4, negative 9? No, negative 4, positive 9. Yeah, negative 4, positive 9. Negative 4, yeah, negative 4, positive 9. So the negative 4, we would divide that by 2. And the positive 9, we would divide by 3. And that gives us the answer. See, even number 17, that one was kind of hard to do in my head, too, because we had that 6. We had 2 lies, so we had to divide each one by a different thing. That's really tricky. I wouldn't recommend doing that unless you are, like, really, really experienced with this. And then last one, 18. So I don't think I'm going to be up for the challenge on this one. Gotta say, sorry, not sorry. Maybe I am. I don't know. Maybe. Let's do it. Let's do it. So we would take out a factor of 4. We'd take out a factor of 4. We'd have 4b squared plus 15b minus 25. Okay, so 4 and 25 make 100, so we'd want factors of 100 that give 15. We'd be subtracting those factors to get to 15. So 1, 2, 4, 4, 5, and 20. Yeah, 5 and 20 would subtract to get 15. We'd want positive 15, so we'd want a negative 4 and a positive, or sorry, negative 5, positive 20. So a negative 5, positive 20. The negative 5 wouldn't have a lie, so it'd be 4b minus 5. We'd have a 4 that we initially factored out. The other one would be the 20, which would divide by the 4, and we'd have b plus 5. And I think that's it. So I'm actually kind of curious to see if I got that one. While I'm checking these answers, let's go ahead and we'll just look at all the answers, and then we'll see if 18 was right. So as we're looking at the answers here, you can look up these answers anytime you want, by the way. You just kind of Google the name of the worksheet, and it'll just pop up. If your teacher assigns these worksheets to you, they normally don't give you the answers. They give you the first part of the worksheet, not this part that you're seeing now that has all of the answers in it. But you can look it up and you can find those answers. And I'm only saying that because I'm not like, advocating cheating. I just want you to like make sure you're getting the right answers. If you're working out all the problems and you're doing the wrong way each time, you're gonna have to unlearn that first before you learn the right way to do it, and that kind of sucks. So, if you're working out some problems, check each one to make sure you're getting the right answer. That way you know you're doing it right, whatever method you end up doing. I highly recommend mine, of course, because mine's the fastest way. And if you want to solve it the fastest, that's how you do it. But there's some other ways to do it as well. And I think I got that one. It was 4b plus 5, 4b minus 5. Yeah, b plus 5, 4b minus. I had them in a different order, but it doesn't matter because when you multiply things, it's all the same. But yeah, 3n minus 2, 2n plus 3. Yeah, I had those in a different order as well, but same thing. So that pretty much is it for this. If this has been helpful and you want to see more free content like this, I have tons of other videos on the channel, of course. But I also have lots of free and otherwise content on my website. You can go check out all that free content on my website. It's myersmathematics.com. The link is in the description below where it's asking you about tutoring, because I primarily, as of right now, as of the time of doing this video, do tutoring. But I'll start to taper off of that more as I start to work on more content like this, and book content and online course content and things like that. Lots of content for you guys to consume and get help. So if that's been helpful, you can go check that out at my website. You can go grab a free resource on there at the main page. You don't have to travel around too far. On the main page, there's a resource called the 5 math mistakes everyone makes and how to avoid them. It's just a general guide for whatever math class you're in. Just what kind of mistakes you're probably making, like categorizing each of them, and then what you can do to kind of not make that particular kind of mistake anymore and start to get math problems right. It's kind of a generalized thing, so it's not specifically for algebra. If you know anybody that could benefit from knowing what kind of mistakes they're making in math and maybe not making any of those mistakes anymore, then point them over to my website, myersmathematics.com, and that's a free resource I have. I try to work on that one the most out of all the other resources that I work on. Try to always tweak that one and make that one really, really good. So I'll continue to be making that one better. If you watch this video years from now, then even more so that thing will be revamped, and it might have a slightly different title, but it'll be pretty much the same thing, and it'll offer the same thing. So anyways, that is it for today. If this has been helpful, go grab some more free stuff, and you can throw a like and a subscribe if you want, but don't really care as much about that. I want to help you get math out of the way. Want math to not be a stumbling block for graduation. I want you to get all of this stuff under the belt, so to speak, so you can move on and get into your career, make lots of money. All right, I'm gonna stop. I'm being really long-winded. Have a great one. I'll see you in the next video.